Alright there, hi everyone. So you're joining me in the dark. It's outside, it's about 5 o'clock in the evening, it's dark here in Cyprus, and what am I doing, you may be asking? Well, I've decided to add another 2 batteries into the solar system, and this is the ideal time to do it as the batteries are started to deplete, and the voltages on the batteries, on the old original batteries, are pretty close to the voltages on the supplied new batteries, which means it's an ideal time to tie them together without having to go and charge them to get them all individually balanced. So arrived in the post today. I've got a whole bunch of new chunky cables for joining them all together. So what I'm going to need to do is connect the 2 positives together, take the midpoints together and then the negatives together, and then I'll probably have to change the bolts on the original batteries because I don't think the length of the threads are long enough to take in the new additional cable lugs. So if we look at the system at the moment, the new batteries are sitting at 12.94 volts. That one's the same, and under load, because there is still equipment running in the observatory, the existing batteries are 12.87, but that'll creep up slightly when I turn off the system. So they're 12.88. So if I turn off the supply to all the equipment in the observatory, we'll see that this is 12.95, the same as the new batteries. So this is perfect. So I've got my trusty shifter, so I'm going to start a bag of bolts and washers, and I'm going to tie them in and hopefully don't short something out in the process, or hope that the cable that I've got an extension lead running to the house, and I brought one of the house lamps outside to give me some lighting. So this is the new batteries, this is going to go into here. So I'm going to turn off, it is off, I've turned off the system. So I'm going to start with tying the negatives. And this means that when the sun comes up in the morning, it's definitely off before I get a load. Yeah. So when the sun comes up in the morning, if it does come up, it's been cloudy today, then the system will charge all the new and old batteries. So looking at the length of these screws and what's already installed, that ain't gonna fit. So I've got some 8mm new bolts of varying lengths. So I've got these 20mm. They'll go in there perfectly. That's fine, they're screwing quite a bit in, so plenty length there. So I unscrew this one. This is a bit fiddly. Locking washer, washer. Okay, that's that one. And I can just pull this back and tighten that. Okay, next I'll do the midpoints. So I've got a bridge for the middle between the 2 batteries at this side, and then another bridge for the 2 batteries at that side, as we can see here. And then I also need, better not short myself across the battery terminals. I don't think that'd be very pleasant. So what I'm also going to do is remove these two. So these are coming away. Make sure that cable end's not touching anything. So that just leaves the positives to do. That's the old bridge. Alright, now we need to get all these in. There's 1, 2, 3, 4, 5, 6, 7 cables going into this, so they better all stay put. And I can see a little spark there as the battery balancer is obviously still working. And I've dropped the locking washer. Shit. Okay, I haven't missed any cables. Just tighten up this end. Alright. That is everything tight. And I haven't missed any cables, which is even better. Alright, so what I'll do now is I'll pick up all these bolts and things, and including the one I've dropped. I'll get that tomorrow because I'm not crawling in under the dome. And we can go into the Victron app and see what the system's doing. So I'll turn on the batteries to the system. There's no magic smoke, there's no big flashes, there's no funny noises, and I'll turn on the solar charge supply ready for tomorrow. And a quick check of all the voltages. So that's 12.96, 12.95, 12.94, 12.93, and across the system 25.8 volts. Excellent. Right. So let's hop inside and we'll have a look at the Victron app and see what it says. Alright, so you join me inside now. After doing the modifications outside, I connected to the various components on the Victron system using the Victron Connect app, and I set the new capacity of the battery bank so the system knows how much power is available to it. So I increased it from the 200 amp hours to the 400 amp hours, obviously adding the two new batteries into the system. So here we are looking at the dashboard, which is the Victron remote monitoring cloud service. It updates about every 10 minutes with data from the solar system through the Cerbo GX, which you can see in a previous video that I did. So what we're looking at here is the overview of the system, and if we look at the bottom left of the boxes, you can see the discharging, so that's the battery status, and we can see the battery voltage is currently sitting at 25.6 volts. And there's 2.7 amps getting drawn off at the batteries at the moment, and the time remaining we can see is 122 hours at the current consumption. So before I made the battery modifications or added additional batteries, I had a quick check and I think it said 56 hours, so that ties in nicely with adding another two 200 amp hour batteries into the system. So why did I want to do this? Well, obviously capacity is excellent for longer periods, and as we're heading into winter now, we're getting longer nights, and obviously there's more reliance as well on the dew heaters and things like that, which all adds additional power demand onto the system. And as if you remember from the previous video I did after the initial install, when I ran both telescope setups as I would normally with the dew heaters running, both cameras cooling and all the normal guiding and things like that, the system didn't have enough capacity to get through the evening. It was about an hour short in the morning before the system started to recharge again. Now obviously I could have gone out to the observatory once I'd finished the imaging session and shut down the cooling on the cameras, and I hadn't set all that up in Nina, but obviously I just wanted to see how long the system would have lasted under my normal conditions had I not done any of that. So since doing that, I have added in some additional actions into the Nina sequencer, so that once the imaging session is finished, it does turn off the cameras cooling, and at the moment I don't have any control over the dew heaters, so they were still running on one of the rigs, the outside telescope. So when I came back from offshore, I set up the system again, and I was just having a play around in the night sky, and I left a test session running, and again the system shut itself off as per my settings in the DC to AC inverter, where I've got a 21 volt low voltage cutoff. So if we go across to the advanced tabs and we look at the 14th, so here's all the data. So the top left chart is showing the status of charge of the batteries, and you can see they continue to decline until it flatlines at what time is that? 6 o'clock, 6:18 in the morning. And if we look at the time it starts to charge up, so the sun's just starting to rise about 8 o'clock, and then it really starts to put power back into the batteries again, and is fully charged by 11:30 in the morning. So there's plenty solar capacity there going into the batteries. And if we look at the inverter output, so this is now the middle graph, you can see the system was running away quite happily, and then at 6 o'clock in the morning, or whenever the timestamp is, the system shuts off and we get this gap in the trend. So that's the AC inverter manually shutting or automatically shutting itself off as per my settings. And if we look at the bottom left chart, we can see the solar charger battery voltage and current. So the blue line is the voltage, and we can see the voltage steadily declines through the night, and then we start to get a rapid tail off around about 5:30 in the morning, and then again it knocks off, system stops drawing power around about 6 o'clock in the morning. Now when the AC inverter goes off, obviously the DC loads, so the system itself, the router, that sort of thing, they're taken direct off the batteries. Sorry, the router isn't, the DC Cerbo GX unit and things like that, the MPPT and all those things, they're taking their power directly from the batteries. But my security cameras, the laptops, they'll all lose their AC power, the mounts will go off, the cameras will go off, all that sorts of things will automatically shut off when I pull the power off the AC inverter. So there's minimal load still on the system, so that I've still got visibility remotely. And then as the sun comes up, we can see the system rapidly starts to charge the system. Here in the middle, bottom middle, you can see the yield from the system. We peak around about 588 watts of power going into the batteries at 11 o'clock roughly, quarter to 11. And then as the batteries are fully charged and they switch into their absorption mode and then into float, there's no demand on the system other than the base loads on the DC system and the laptop running and things like that. So that's why I wanted to add additional power into the system, so that we've got reduced chance of the system shutting down. Now we'll just continue to monitor. So if technically I've added double the capacity onto the battery system, so we shouldn't be in a position where the system will shut itself off under normal running. Once I get the system fully charged again, so tomorrow I'll see how it resynchronizes. So I've added additional batteries that needs to learn again when the system's fully 100% charged. And then we'll set up the telescopes again and just see how we got on with another full capacity test on the system. So anyway, that's it. Just another quick update on the mods to the solar battery system. So that was increasing the capacity from a 24 volt 200 amp hour system to 24 volt 400 amp hour system by the addition of two 200 amp hour batteries onto it. Alright, so thanks for watching. In the next video will probably be more about the DC systems. I've started the mods on there to pull the dependency off the inverters and give me obviously some more in finite control or granular control of the individual devices, supplies and things like that. So that'll be hopefully coming soon. Alright, thanks for watching then, and we'll see you in the next one.